And the last half of 6.5 deals with using synthetic division. Now, synthetic division is the exact same thing as synthetic substitution. You do the same process. It's called something different this time. The reason that it's called something different is because what you're going to be able to do is you're going to be able to divide out polynomials using synthetic division. There's two parts here, so I'm just going to do the first one. You're going to be able to divide, given a term, into a polynomial much easier and more efficiently than long division. Here's what happens. When you are given a term, x minus 2, that's what's in parentheses. Do you guys agree? That would be a term. What would be the 0 of that term? 2. So the 0 of this term is 2. And when we're using synthetic synthetic division, we're always going to divide by the 0 of some specific term. That's like the only rule there is. So going into division here, I'm going to take, remember what we do is just take out all of our coefficients, put zeros in for placeholders if we need be. So when I do that, I'm going to have a 2 on the outside, because that was my 0, this was my term. Okay. When I put all my coefficients in, we've got a 1, 2, -6, and -9. We all remember this now, right? You guys were good at this. This was easy. This made you happy. Okay. Drop that, multiply, add, multiply, add, multiply, add. Same thing we did before. Multiply, add, multiply, add, multiply, add. So when we did this before, we'd say that f of 2 would wind up equaling -5. Remember that? You get your, that's how you got your ordered pairs, that kind of thing? Bless you. It's this, what we're doing here now is that this is a way of factoring. Because in the next example, same numbers here. Oops. Let me just put it on a separate sheet here to see you real quick. When I look at part B, if I'm going to do part B, my term is x plus 3. Therefore, what would be my 0? -3. -3, good. So let's divide by the -3. 1, 2, -6, -9. I'm going to use synthetic division with that. As I go through that, same process. Drop the 1, multiply, add, multiply, add, multiply, add. Notice how I get a 0 at the end. That confirms -3 is a 0 of this function. Still get 0, right? Did I just make the wrong right mistake?
You still get 0. Who's that with that 0?
Thank you. I didn't realize I did that. Yes, sir.
How do you just get x plus 3 and x minus 2? You just guess?
There's a method to get them, but for today you will be given terms or you will be given zeros. Okay? Tomorrow we'll talk about how you find them on your own.
Okay.
All right?
Is 2 a 0 also?
No, 2 was not a 0 because it had a remainder of -5. See how this one, how it differs a little bit here? We wound up with, oops. We wound up with a remainder of -5. Yeah. That meant it was not a 0 because it would have a 0 at the very end. So when you go through this, I know that -3 was a 0. So think about what you did yesterday. When you did that yesterday, you guys did the long division. You had x plus 3 on the outside. You went into x cubed plus 2x squared minus 6x minus 9. How do you turn an x? Yes, ma'am. I'm showing you how this works. How do you turn an x into an x cubed? You multiply it by x squared. Distribute back. Subtract out. You get a negative 1x squared. How do you turn it? How do you turn an x into a negative 1x squared? Negative 1x. It's up a bit. So you have negative 1x squared minus 3x. Subtract it all out, you get negative 3x minus 9. How do you turn an x into a negative 3x? Negative 3. And you had no remainder, right? What do you notice about this? That. It's the coefficients. It's the coefficients less 1 degree. Notice how you started with the cubic, third degree polynomial? And if you divided it by a regular old term, which had a degree of 1, you went down 1 degree. Basically, what you're telling me is the following. X plus 3 times x squared minus x minus 3 equals x cubed plus 2x squared minus 6x minus 9. What you're telling me is that happens. You factored out something you couldn't factor before. You found out that x plus 3 was a term. Negative 3 is a 0. Because if you looked at this problem 2 days ago, when we were factoring these polynomials, you would try to group that. Do you agree? Because it had 4 terms. You try to group that, you get a GCF, you take out the x squared, you get x plus 2. Here you try to take out a negative 3, and you have 2x plus 3. Non-factorable, right? You factored the unfactorable.
So it is factorable.
It is, because now we have another method.
I understand what you're doing here, but how does that correlate to the grouping? Like, how does making that second
Sometimes it doesn't work. You know how sometimes grouping doesn't work, or you can say something's not factorable? Well, we said that before. We did quadratic, we did completing the square. Now we're taking these larger degree polynomials when we're able to find zeros from a different method. Synthetic division allows you to find zeros from terms or from given zeros. You can factor things out this way. Yes, sir?
Why do you have 2 red arrows pointing at? Do they correspond with something? Or?
See how this is a, what's the coefficient of this?
Oh, 1.
What's the coefficient here? What's the coefficient here? 1, negative 1, and negative 3. Those are my coefficients. I'm sorry I'm keeping you awake.
So long division is one way of factoring.
Okay. Long division is a way of factoring as well. Okay. Once again, I'm going to divide this out. I'm going to divide this using synthetic division. We're going to divide using synthetic division. Exactly. What you're looking at doing here is, when we use synthetic division, we're always worried about placeholders. My term here is x plus 3. What's my 0? So I start with my negative 3. I put in my coefficients. 1, 0, negative 8, and 3. You have to have placeholders for this to work. Okay? You go through the process. 1, negative 3, 9, 1, negative 3, 0. So, is negative 3 a 0 of that function?
Yes.
Yes. Therefore, if you think about when we did factoring over the past few days, could you factor that right off the top of your head? No, you'd say no solution, go to the next problem, right?
Yeah.
Au revoir, Mr. Go Fair. Because what happens now, you know that x plus 3 is the term of the 0. When I rewrite my problem, I know that it started as a cube. If I take out an x, what does this drop it down to? X squared. It always goes down 1 degree.
Are you gonna say
You
about
just-
some problems in the homework that have like an x squared minus 9 or something like that?
You'll see how it goes. All right. You guys just always worry about everything before you have a chance to see it all. So just let it happen. Yes, sir.
What if the solution wasn't 0?
Then it's not a 0. Okay. What happens here is you're going to be given a lot of these that will be zeros to start with. It'll say such and such is a 0, such and such is a term. If you don't get 0, that means you did something wrong in here. Okay. For a lot of this stuff today. Okay. That builds into what we're going to do tomorrow. Like Clay was worrying about, what happens when you don't know where to start? Well, there's a process to know where to start. We'll get to that. Why does this work? What happens here is you've got something divided by something out. You're trying to see what are all, let me ask this, what are all the factors of 12? What you're doing here is you're doing a factor tree of a polynomial. And there's, instead of using just numerics, you're working with terms. It's a weird way of doing that. Okay, if you think of it that way. Now, if I go to the other one I had here, what's that? No.
Yeah, every time we hear that,
Yeah.
he's actually.
No. There's, I could hook up the dock camera and we could do that if you want, but it's just too much of a hassle. So here I'm going to do x to the 4th minus 16x squared plus x plus 4, and I'm going to divide it by x plus 4. So if I'm dividing by a term of x plus 4, what is its 0? Negative 4. Good. So I have negative 4 to start with, and I'm going into 1, 0.
Negative 16, 1, 4.
Okay. You go through the process again. 1, negative 4, negative 4, 16, 0, 0, 1, negative 4, 0. It's a 0. Correct. So that means that that is a factor term of it. So what happens here is we started with an x to the 4th, a 4th degree polynomial. This becomes what? X to the 3rd. So when I write this out then, it becomes x plus 4 times the quantity, x cubed, minus 4x squared, plus 1. Yes, sir? Yes, if you want to put 0x in there, that's perfectly fine. I'm going to start to not do that, just because I don't need to. I'm saving it.
Wait, so are these equations we're making just like the difference between things?
Pretty similar. What you're doing here is we're starting with a polynomial that you would want to think that you could factor by grouping, but you can't.
It just turns out to be the, like,
I know.
difference of cubes.
It not necessarily.
But they don't like.
It looks like it could, but
say.
this is another way of doing it. Clay, and I'll get you right next.
What happens when it equals 0? Like, how do you solve x cubed minus, like, do you have to factor even more to make
We'll get there.
zeros?
Yes. Right now we're just factoring.
Okay.
Eventually we'll take this a step further and find all possible zeros. Now, when I get to this, I can't factor that. But if it was an x squared minus 4x plus 1, I could. I might not be able to do it a quick, easy way. I might have to use quadratic formula. But I could find all my zeros. What was it? That was it? What do you got, John?
Okay, so to get the x cube
Mm-hmm.
and minus, okay, so with that, would you just divide the big huge, like the x to the 4th, would you divide that by x plus 4?
Yeah.
Oh, is that all it is?
That's all it is.
Okay.
But it's a lot easier to use synthetic.
Yeah.
The only thing,
The equation at the bottom of the.
this is
Oh,
This is-
okay, I see how you're doing that now. Okay, I didn't understand how you were doing that.
What I'm doing here is the answer that when you divide it out is this. What I'm doing is I'm showing you how this becomes factored into this. I'm getting to that. I'm pushing you to what we're going to be doing next. All right? The other thing that I've been asked quite a bit about today with some of these is, does it work with something like number 21?
Try it, do it if it wants.
Well, here's the deal. It's an x squared term. It's possible, and it starts to get messy, okay? What you wind up having to do, it's much easier to do this with a singular zero. If you know one of your zeros, everything else will fall into place. I'll show you how to get to that, but just not today.
Okay, but is no one, because this is a positive one, you just get used to positive?
Yes, but sometimes it's not as clear.
Yeah, but
Okay.
okay.
So another way that they're going to say this is you're going to factor the polynomial when they give you a zero. And they write this out a couple of different ways, and I want to show you how it looks. In this example, f of x, telling you it's a function, 2x cubed plus 11x squared plus 18x plus 9. 3-4 days ago, we would say, okay, it's got 4 terms. I would try to factor by grouping. Then you would find out that you can't. So you'd say, no solution, go to the next problem. Now, I'm telling you that there is a zero located at -3. If -3 is my zero, what is my term? X plus 3.
Oh,
So if -3 is the zero, that means the term is x plus 3. Is we okay with that? I want to get you guys in the habit of writing down, if you're given a term, what's the zero? If you're given the zero, what's the term? I just want to get you guys in the habit of doing that. It's going to make 6.7 easier. Okay? So if I use synthetic division, I'm dividing by my zero, -3, 2, 11, 18, and 9. Hopefully you get a zero because it told you -3 was a zero. We just verified that. Okay? We just verified that -3 was a zero. If you don't get 0 here, it means you did something wrong. Okay?
Then it's
So now we know that we're factoring this out. I know that I have x plus 3, and then, go ahead.
2x squared plus 5x plus 3.
Now, can you factor that?
yeah.
Yeah.
Two problems.
times 3 is 6, and then
That's right.
oh, it is right. Okay, and then 6 minus.
Yeah, what happens here is that you can factor that trinomial, hopefully, you remember how. 2 times 3 is what? What is 6 that you add together to get 5? 2 and 3. So you wind up factoring it out by grouping.
Yeah. But that's negative.
Take your GCFs now. So you're going to have to do a little bit of everything in some of these. You'll have to do some trinomial work. You might have difference of squares. Every once in a while, I don't think it shows up, but you might see a sum or a difference of cube. So your 3 terms in this problem become x plus 3, x plus 1, and 2x plus 3. That is how you factor the unfactorable. Now it's not. Now it's,
Is there ever anything that's like completely
oh, sure there is.
Yeah, thank you, Jenna.
But we're just not worried about those. So what we're doing is we're basically adding another method to factoring. Factoring given a zero, factoring given a term, you can continue to go that through. The next basic progression in these steps then would change to find all other possible zeros. You know -3 is a zero. If I put a equal 0 on here, what are my other 2 zeros?
-1 and -3 over 9.
Okay?
She said she did. No, I didn't.
Whatever. It's just the next natural progression of the problem. You're given specific values, you continue the process, you rewrite, you factor, the next step would be zeros. So, one of the zeros of this function is 2. If 2 is a 0, what's its term?
It's x minus 2.
Okay, find all the other zeros, which means factor this completely.
Oh, yeah.
So, I know that 2 is my 0, so I start with the 2 on the outside. Coefficients, 1, -2, -9, and 18. And I got that, right?
Yeah.
Okay. My term was x minus 2. And this becomes x squared minus 9. So, if I'm finding all possible zeros, do I need to continue to factor the x squared minus 9, or could I just write down plus minus 3? If you want to, it's fine. I have no problem with that. If I'm looking for finding all possible zeros, oops, and you want to write down all of your factored terms first, no big deal. Because the other thing this allows you to be able to do rather quickly is also graph. If you have zeros, where is it crossing the x-axis? 2, 3, and we know that it's a cube function with end behavior going like this. So we know it's got to look like this. It's the same basic stuff we've been working on. We're just leading into that more and more and more. Find all my zeros of this one, please. You are given 10 is a 0.
Oh, that's
10 is a 0. Yeah, it said that in the instructions. I just kind of moved it around so you can see it a little bit better. 10 is a 0 of the function. So if 10 is a 0, what is its term?
X minus 10.
Good, good, good. Please find all other possible zeros. So let's see here. I know that 10 is my 0. 2, -14, -56, -40. Oh no, those are scary looking large numbers. I hope this works out well for me.
You could be the next series.
40, 0.
Okay. So you wind up with coefficients of 2, 6, and 4. I know that 10 is a 0. If 10 is a 0, my term is x minus 10. Here I get 2x squared, 6x plus 4. Now remember, we're trying to identify all possible zeros. Now Clay, this is what you were asking about with the GCF. Now I get down to that trinomial, and I've got all 3 parts of that trinomial are all even. Can I take out a 2?
Yes.
Does that 2 have any bearing upon the problem whatsoever?
No.
No.
He's a screw.
It makes your life a lot easier.
It sure does.
If you take out the 2, you have x squared plus 3x plus 2.
Factor, so x plus
Does
1 and x
that,
plus
so what do I do with that 2 then?
1 is gone.
It's gone, right? Because we're finding zeros. Since the 2 is a constant, it has no bearing upon the problem.
Yeah.
Okay? So you wind up with
X plus 1 and x plus 2.
your 3 zeros then are located at 10.
-1.
That's all it is. 10, -1, and -2.
Your 2 looks like a 6.
What if you didn't?
It's a mathematics.
You still get the same answer. Yeah, if you don't take out the 2, you still get the exact same answer. You just have to go with that grouping method, which is a little bit longer. That's all.
Your 2 looks like a backwards 6.
Oh, and it works the same that. Just remember, hey guys, remember what you're doing at these steps. When you get to this spot here, you're factoring a trinomial. There are many methods as to factoring trinomials. Grouping, completing the square, quadratic formula, any one of those works because you're looking for zeros. When I sit there and I think about what's my first rule of factoring, well, is there a GCF? Get rid of it, it becomes something faster. What you did is not wrong. It's just quicker. There's other methods that are a little bit easier to work with. That's all. Okay? I'm not going to say don't do it that way, but if you recognize it, it's just easy. Okay?
You're wrong.
She's not wrong. That's not what I wanted you to do.
Cole's wrong.
Let me give you some props.
No, we can go without that one.
You just come up
You
with
know,
these off the top of your head.
No. It wound up, I was originally going to try and do all this in a day, then I decided probably not a good idea. Page,
Makes all suck.
Speak for yourself.
I will remind you that when you're factoring some of these problems, you get down to a trinomial. The only method that you can factor something sometimes.
No.
Oh, man.
And also notice that we're finding all possible zeros.
The imaginary one?
Which means imaginary could pop up.
Wait, we're gonna use that?
You might have to. Just a reminder.
I gotta use that. I forgot how to use that.
When you're working with all
Shut up.
Flash it.
I got you.
You're right. In a real world, real
Play, write it down.
job. Yeah. Don't let the imaginary numbers mean you down.
Can it be?